All right, this is the Algebra 1 new Unit 7 study guide. For those of you who are getting ready to test, I'm going to go over questions here that are on the basically the same types of questions you're going to see on the test. So I've gone through the test, I've looked at the questions that are on there, and I've basically created questions that are similar, but with some slight changes just to kind of show you the skills that you need for the test. So I'm going to go through this in a slightly different order than the numbering. Actually, let's just go ahead and go through this in order. So looking at this first set, this first problem deals with scientific notation and division of scientific notation numbers. So I'm going to kind of show you the way this is set up. So here we have 2.389 times 10 to the fifth divided by 2.040 times 10 to the third. Now what you have to realize is that either side of this can be worked out separately. So I'm going to work out the 10 to the fifth divided by 10 to the third, and then I'm going to work out the other portion as well. And then I'm going to get two-part answer, and then those answers together will be the scientific notation answer. So like 10 to the fifth divided by 10 to the third illustrates one of the exponent rules that we dealt with. Because we know that when there's numbers with exponents being divided, if they're the same base, which these are 10 and 10, I can subtract the numbers. So 5 minus 3 means I'm going to have times 10 to the second as this part of my answer. Then over here, 2.389 divided by 2.040, we're going to run over here and do 2.389 divided by 2.040. I'm just doing that in the calculator, and I get 1.171. And so what's great is that is 1.171, and that is the final result. So you can see you just do each part separately, put it together to get the final answer. There will be more scientific notation questions here later in the review. Next one, simplify and evaluate the expression. All you're doing here is you are using exponent rules first to simplify the expression, and then you're going to plug 2 in for x. So for instance, x to the third divided by x squared. That's going to be x to the first, because 3 minus 2 is 1. And then x to the third squared means 3 times 2, x to the sixth. So these rules you are going to need to definitely have in front of you and be familiar with using them, because you need to know what to do when you have this type of expression or this type of expression. When they're divided, you subtract the numbers. When it's a power raised to a power, you multiply them. So then we go in and we plug in 2 to the first plus 2 to the sixth. 2 to the first is 2. 2 to the sixth, we'll run over here to our graphing calculator. 2 raised to the sixth power is 64. 2 plus 64 is 66, and that is the final answer for that problem. So again, use the properties first and then plug in the 2. Really, you could plug in the 2 from the beginning. It would just take more work in the calculator to get the answer that way. All right, next one, we have a word problem dealing with exponential depreciation or decay. The formula for this, and I will post all the formulas in one place when I post the review video, is the following. A equals P times 1 minus the rate raised to the time. So this is the exponential decay equation. The final amount is equal to the initial amount times 1 minus r raised to the time. So again, watch the videos from the previous lessons if you're not sure about what all these values are. I'm kind of going through it as if we know that already because we've done it in a previous lesson. So when I actually plug this in, it's going to look like this. It's going to be P, which is 12,000, times 1 minus 0.03, which is the depreciation rate, and then raised to 5. So I'm going to go type this in over on my calculator. So it's going to be 12,000 parentheses 1 minus 0.03 raised to, it's this button right here, raised through the fifth power, 10,304, 81. 10,304.81, and that is the amount at the end of 5 years if it depreciates at 3% for 5 years. So that's it. So that's your formula. If it's growth, you'd use the one that has plus R. And then there are other formulas as well. We went over that in lesson 6. So make sure you go back and look at that video if you aren't sure what to do there. All right. Another one, this is another interest formula problem. I'll go ahead and write the formula here for us. The formula is that the amount equals the principal times 1 plus R divided by N raised to the N times T. And this is the compound interest formula, okay? And that's because we have per month. That tells me it's compound interest. And that means that the N is going to be 12. So let's plug everything in. So P is 4,000. 1 plus 4% divided by N, which is monthly, so 12, times 12 times 10 years. That's a lot going on in that problem. We should be able to type this in all as one. So I'm going to go and show you how to do that. So we're going to have 4,000 parentheses 1 plus, and then we're going to do 0.04 divided by 12. Then we're going to close those parentheses, and we're going to raise that to 12 times, to do that, you're going to need parentheses around that, 12 times 10. I noticed that I put my exponent in the parentheses so that I could multiply. Now, I could have already done the multiplication there, which is going to be 120, 12 times 10, and I could have typed it like that. But if you're going to type it all in at once, you got to put parentheses there so the calculator knows to put that multiplication in the exponent, not down on the main level. So that's everything right there, and I get 5,963.33. 5,963.33. And that's the final amount. All right. Next one has me simplify this expression, this algebraic expression. And so it says here that I've got 5 to the 0, a to the negative 3, b squared, divided by 3, b to the negative 4th, all raised to the 3rd. Now, I want to, before doing anything with the 3rd, I'm going to simplify everything inside. So let's talk about that. So first of all, 5 to the 0, that becomes 1. The 3, again, nothing happens with the 3. So that deals with this and with this. A to the negative 3, because it's negative, it needs to move below the line. So that's going to become a to the 3rd. The b squared is going to stay, but the b to the negative 4th on the bottom is going to move up and become b to the 4th there. Again, all raised to the 3rd. I'm going to go ahead and do one more step of simplifying before we do the final part, which is to say I'm going to go ahead and grab this and move it over here. So I know that we're going to have 1 b to the 6th, because those b's multiply together, and then we have 3 a to the 3rd, all raised to the 3rd. So now that 3, like all exponents outside of parentheses, gets distributed to everything in that. So that's where we're getting the fact that we have 1 to the 3rd, which is 1. B to the 6th to the 3rd is B18 now. 3 to the third is 27. You can do that in your calculator if you need to. 3 to the third. And then a to the third is 3 times 3 is a to the ninth. And that's our final answer there. So you will see a question very similar to that on the test. So just kind of make sure you look carefully at the example I gave you here and the ones we did in the previous lesson. Follow all of your exponent rules, and I think you'll be fine. All right, we have some formulas we're going to need for these. First of all, geometric sequence. Formula is AN equals A1 times R to the n minus 1 power. So if we want to find the 8th term, first of all, my A1 is negative 2. My R is whatever I'm multiplying to get from one number to the next. Looks like I'm multiplying by negative 3. Yep, negative 3 gets me there. And then N is the 8th term. So we're going to go ahead and plug everything in. A to the 8th equals negative 2 times negative 3 raised to the 8 minus 1 power. We can go ahead and simplify that. Negative 2 times negative 3 raised to the 7th power. Let's see what we get. We're going to type it in as close to that as we can. So it's going to be negative 2 times negative 3. We're going to put negative 3 in parentheses, raised to the 7th power. 4,374. And that is the, what was that? The 8th term. All right. So the next one says find the sum of the geometric sequence. The formula here is A1 times 1 minus R to the n divided by 1 minus R. I'm going to make sure that sum of geometric series, make sure I get that formula right. Yes, 1 minus Rn, 1 minus R. All right, just want to make sure I had that correct. All right, so let's go and identify our values. We know that A1 here is 3. We know that N is 12 terms, and R is the number we're multiplying to get from one to the next. That's going to be 2. We're multiplying times 2 each time. So then we go in and we say 3 times 1 minus 2 to the 12th divided by 1 minus 2. Go ahead and grab these guys and move them over. So let's go in here and figure all this out. We can type this entire expression into 1. So we're going to do 3 times, parentheses, 1, and we're going to put another parentheses, 1 minus 2 to the 12th. We're going to close those parentheses, divided by 1 minus 2. Notice how I type that in. You don't absolutely have to have those parentheses, but if you do, it helps you type it in. So when I do that, I get 12,285. So that's what you do. I will put the formula for the sum on the review as well, on the study guide answers. Next, we have scientific notation. Not a lot to say here. Just remember that when you move this way to get to that where there's one number in front of the decimal, you count the spaces. I moved 5 spaces, and since it was a very small number, it's going to have negative. And then here, oops, sorry about that. 1, 2, 3, 4, 5, 6, 7, 8. To get to 1.24, I moved it 8 times, so it's going to be 10 to the 8th. So large numbers get positive exponents, small numbers get negative exponents. you need to watch the video and review there if you need help with this. This is a pretty basic concept here, and we've gone over quite a few examples already. On this one, going the other direction, this has a negative already. That tells me that I'm going to move my decimal place from here in front of the 2. 1, 2, 3, 4, 5, 6, 7. I'm going to add zeros for every move that I made. And so this is going to be 0.00000002. Similar data here. I'm going to move this 1, 2, 3, 4, 5, 6. I'm going to add zeros for the ones that I added, and it's going to be 74000000, and that gives me my answer there. So the number tells you how many number of spaces, and then the positive or negative tells you which direction to move. Positive numbers move to the right, negative numbers move to the left, and of course it's the opposite when you're talking about going from scientific, from standard to scientific. So that's just a couple of examples of those, so you know. And then we get to exponential regression. We have a way to do this on the graphing calculator. The link is in the video description that we had used before. I have it right here. So I'm going to go ahead and type all of this information in. This is what you're going to do. You're going to open this exponential regression graph. Go ahead and have that link handy. And we want to find a form of the equation that is y equals abx. So we're looking for a and b for this. So here we go. Let's go 0, 2, 4, all the way to 16. 2, 4, 6, 8, 10, 12, 16. 2, let's go ahead and put those numbers in. You're going to do exactly what I'm going to do. 2, 4, 6, 8, 10, 12, 16. Let's get rid of that. Oops. Oh, there's a 0 as well. Let's go ahead and put that in. I'm going to fix this. There you go. Let's get rid of these other rows. Then we're going to add these numbers, 25, 36, 52, 68, 85, 85, 104, 142, 260. All right, so we can see it graphed everything for us already. Kind of look at the points there, and it gave us the values. A is equal to 26.84, and B is equal to 1.15. So if I were to convert that, it would be y equals 26.84 times 1.15x. And that's all you got to be able to do. The other half of this type of question is just predicting what the answer will be for a particular number. And to do that, you plug in that number for x. We did examples of that in the lesson, so I won't spend time on that. Next one, just a reminder of how to simplify radicals. We have a square root. That means everything is having the square root taken. The easiest way to do this is to rewrite this as parts of things that can have the square root taken of them. Notice I split the a up. I split the 64, I break off. The b, also break it up into squares. What's nice is when they all simplify. So this becomes 8. This and this become a and a, or a squared. And we have an a left over on the inside. That's this guy. 121, the square root of 121 is 11. Then we have b, 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 or b to the third, and that is it. Not too bad, really. All right. Lastly, pretty easy questions here. This is just a multiplying exponential expressions. Remember, when you multiply numbers that have exponents, you add their exponent numbers. So this becomes really, in a sense, this and this. because the 10 and the y1 come over here, the x3, x6 come over here. So it becomes x to the 9th, y to the 11th, and that is it. That easy. Now this introduces some numbers. 3 times 4 is 12. Then a becomes a to the 4th. 2 plus 2 is 4. And then b, we have 6 and 2, b to the 8th. Just review your exponent rules. All of this stuff was covered in the lessons. Again, this is just for you to have some practice. Then lastly, which of the following represents an exponential function? Remember, x is the exponent in an exponential function. So this one, x is not the exponent. This one, x is not the exponent. Only in this one, yes. Because x is right there. All right, that is it. Besides the last little section here, which I want to make sure to point out, there are some vocabulary words that you need to look at. Just real quick down here, key concepts. Go back and check over the definition of asymptote, what happens for decreasing versus increasing exponential functions, and what do you know about the domain and range of exponential functions. That is all covered in the lessons and in the notes. All right, that is it for our study guide review. Good luck on the test. Please reach out to me if you have questions.